Albert Einstein, one of the most renowned physicists of the 20th century, revolutionized our understanding of the universe with his groundbreaking theories. His work fundamentally altered the fields of physics and cosmology, and his ideas continue to influence scientific thought today. 1. Theory of special relativity. One of Einstein's most famous contributions is his theory of special relativity, published in 1905. This theory changed our understanding of space and time. The key principles of special relativity are: the speed of light is constant. According to Einstein, the speed of light in a vacuum is always the same, regardless of the motion of the observer or the source of the light. This was a radical departure from previous theories, which assumed that speeds could simply be added together. Time dilation and length contraction. Einstein showed that time and space are not absolute. Time can slow down, time dilation, and lengths can contract, length contraction, for objects moving at speeds close to the speed of light. This means that two observers moving relative to each other will perceive time and space differently. Mass-energy equivalence, E equals mc squared, perhaps the most famous equation in physics. Einstein's E equals mc2 equals mc squared equals mc2 expresses the idea that energy, E, and mass, m, are interchangeable. They are different forms of the same thing. This equation explains how a small amount of mass can be converted into a large amount of energy, which is the principle behind nuclear energy and atomic bombs. 2. Theory of general relativity. In 1915, Einstein expanded his ideas into the theory of general relativity, which provides a new description of gravity. This theory was even more revolutionary than special relativity and is one of the cornerstones of modern physics. Gravity is curved spacetime, unlike Newton's theory of gravity, which described it as a force between two masses. Einstein proposed that gravity is the result of the curvature of spacetime caused by mass and energy. Massive objects like the sun bend the fabric of spacetime, and this curvature directs the path of objects, which we perceive as gravitational attraction. Predictions of general relativity. The theory made several key predictions, many of which have been confirmed by observations. These include: 1. Gravitational lensing. Light from distant stars or galaxies can be bent around massive objects like galaxies or black holes, which acts as a lens. 2. Time dilation in a gravitational field. Time runs slower in stronger gravitational fields, meaning time moves more slowly near massive objects like black holes. 3. The expanding universe. General relativity provided the framework for understanding the expansion of the universe, leading to the development of modern cosmology. 3. Photoelectric effect. Einstein's work on the photoelectric effect was another pivotal contribution, for which he was awarded the Nobel Prize in Physics in 1921. 1. Quantum theory of light. Einstein proposed that light can be thought of as both a wave and a particle, a photon. 1. He showed that when light shines on certain materials, it can eject electrons, but only if the light has a minimum energy threshold, or frequency. 1. This work provided crucial evidence for the emerging field of quantum mechanics, suggesting that energy is quantized. 4. Brownian motion. Einstein also made significant contributions to statistical mechanics through his explanation of Brownian motion. 1. Molecular theory of heat. In 1905, Einstein explained that the erratic movement of tiny particles suspended in a fluid, observed by Robert Brown, was caused by collisions with molecules of the fluid. 1. This work provided empirical evidence for the existence of atoms and molecules, which were still disputed by some scientists at the time. 5. Unified field theory. Attempts. Later in his career, Einstein sought a unified field theory, an ambitious attempt to bring together all the fundamental forces of nature, including gravity and electromagnetism, into a single theoretical framework. Though he did not succeed, this effort laid the groundwork for later developments in theoretical physics, including the search for a theory of everything. 6. Impact and legacy. Einstein's work reshaped modern physics and altered our understanding of reality. His theories of relativity changed how we view space, time, and gravity, while his work on quantum mechanics helped pave the way for technologies like semiconductors, lasers, and quantum computing. Einstein's influence extends beyond science. His reflections on society, philosophy, and ethics have also made him an enduring symbol of intellectual curiosity and humanism. Albert Einstein's contributions continue to be foundational in the ongoing exploration of the universe, illustrating the profound impact of his work on both science and human thought.